Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for previous NEET questions from the chapter Potential and Capacitance. In the previous video, I explained up to question number 10. Now today, let us continue from question number 11 onwards. The question number 11 is, there are 27 drops of same size are charged to 220 volts each. They combine to form a bigger drop. So we need to calculate the potential due to bigger drop. So remember, potential due to a charge is 1 by 4 pi epsilon naught Q by R. Yeah. So this is, you call it as potential due to smaller charge. So radius of the smaller, this is a distance from where you are looking for potential. This is charge. Now, potential due to, after you merge, it becomes a bigger drop. So this is going to be 1 by 4 pi epsilon naught. Then, so this is now radius of the smaller drop, you call it as the charge of the bigger drop, radius of the bigger drop. Okay, so before you merge, after you merge, charge of the bigger drop becomes number of charges and the charge of each drop. When you merge, volume remains constant. Volume of the bigger drop is equal to N into volume of the smaller drop. So therefore, get back the formula for the volume of the sphere, because drop appears like a sphere. It is 4 by 3 pi r cube. 4 by 3 pi r cube is equal to N into volume of the smaller, 4 by 3 pi small r cube. So 4 by 3 and pi, both sides get cancelled. So R is equal to cube root of N with the small r. Now, so let us substitute here. Potential of the bigger drop is equal to 1 by 4 pi epsilon naught. Q big is what? N into Q. Radius of the bigger drop. So therefore, N to the power of 1 by 3 with R. So just you segregate this portion. This is the potential of the smaller drop. So therefore, N 1 minus 1 by 3 with the potential of the smaller. So in the question, potential of the smaller is given 220. So this is going to be N to the power of 2 by 3 with potential of the smaller. So is equal to V big, potential of the bigger drop. So therefore, N is given 27. 27 can be written as 3 cube with the 2 by 3. And potential of the smaller drop is 220. So this 3 and 3 get cancelled. This is going to be 9. 9 into 220 is equal to, this is 1980 volt. So based on this particular concept, you can also expect questions to come like this. Suppose let us say potential energy stored after you merge number of drops. So get back the formula for potential energy of two charges, potential energy of two charge systems. So 1 by 4 pi epsilon naught. So it is a Q by Q big. So you'll get 2 Qs and Q big by R big. So therefore you substitute 1 by 4 by epsilon naught. So therefore Q big is, what did you write? N cube. One more Q big is that N cube. R big is what? N to the power of 1 by 3 with the small r. So therefore this is going to be 1 by 4 by epsilon naught. Q square you'll get Q into Q. So therefore this, you just continue to have R here. N square minus 1 by 3 you'll get. So therefore after you simplify, energy of the bigger drop, energy stored in the bigger drop is equal to N to the power of, this is 3 to the 6 minus 1, 5. 5 by 3 with the, so if you segregate this portion, This is energy of the system of smaller charges. So therefore, this is small. So maybe in the next exam question may be prepared like this. Even you can also find out capacitance. Capacitance of the sphere is going to be C is equal to 4 by epsilon naught. Directly you can write R big, you can write. So this is capacitance of the bigger drop. So C big is equal to, it is going to be 4 by epsilon naught. Just now you mentioned R big as n to the power of 1 by 3 with R. So therefore this is capacitance of the smaller. So therefore C big is equal to n to the power of 1 by 3. So n value is given. So this is capacitance of the smaller. So maybe you can also expect a question like match the following. Yeah, moving to the next question. Question number 12. The equivalent capacitance of the combination shown in the figure. So this is given 21 NEET. Remember this particular capacitor is shorted. So therefore it is in inactive mode. So only need to consider these two capacitors. These two are in parallel. Get back the formula when capacitors are parallel. It is C1 plus C2. But as per the question, the capacitors are identical. It will be C plus C only. So this is going to be 2C. So second option is correct. Moving to the question number 13. The angle between electric lines of force and equipotential surface. What is equipotential surface means? That potential from the given potential due to a charge at the given points must be same. So in the previous chapter, that chapter before this is field lines, electric fields and charges. You have learned that if it is a positive charge, field lines starts. This is one of the property of electric field lines. Field lines from the positive charge. Even you can take negative charge also. Field line tends towards the negative charge. These are all the field lines. You can try infinite field lines like this. So therefore choose points, but which must be at the same distance from the respective charge. Charge is at here. So therefore, let's say this is a point A, this is point B, but it is also at R from the respective charge. C, it is also at R from the respective charge. This is point D. This is also at R from the respective charge. It is just like the net of the spider. So this is point E, which is at the same distance. This is point D, which is also at same distance. This is point E, the distance, then EF. So therefore, if you join, how it looks like. So therefore, this is nothing but equipotential surface. Yeah. So therefore, this is the direction of the electric field at that point. This is the direction of the electric field at that point. Therefore, this is equipotential surface. So equipotential surface is at 90 degrees to the direction of the field. The direction of the field. Yeah, so first option is correct. Moving to the next question. Question number 14. Two hollow conducting spheres of radii R1 and R2. R1 is greater than R2, having equal charges. The potential would be, so equal charge. So only thing is that we need to concentrate on only radius. Remember, surface, this is sigma is nothing but surface charge density. Surface charge density. So therefore, it is going to be charge per area. Charge per area. So as per the question, area of the R1, because radius is more, area of the R1 is more. So area of the R1 is more means sigma will be less, because radius is more. Yeah, let us write this is the potential formula. V is equal to 1 by 4 pi epsilon naught Q by E. Q by R, sorry. This potential is R only. So let us try to replace Q as Q is equal to sigma into A. So therefore, 1 by 4 by epsilon naught, 1 by 4 by epsilon naught, Q can be replaced with. So this is going to be A divided by R. So therefore, suppose this is of radius R. So what you can expect is surface charge density. You can expect that within the small surface, for the case of small sphere, you can expect more number of charges to get included. Whereas in the larger sphere, within the small area, you can expect only less number of charges to get included. So area must be same. Whatever the small area you are taking, that must be same. Therefore, in case of smaller sphere, if you draw the surface area, which includes less charges, so therefore sigma will be more. Sigma more means potential is more. So therefore, potential is more on the smaller charge because it can have this particular surface will have more charges. So therefore, potential due to smaller sphere will be more. Fourth option is correct. Moving to question number 15. A capacitor of capacitance C is equal to 900 picofarad is charged fully by 100 volts battery B as shown in the figure. Yeah, so this is the figure. Then it is disconnected from the battery, connected to another uncharged battery, uncharged capacitor of capacitance. So first one is 900, even second one is also 900 picofarad shown in the figure. The electrostatic energy stored in the system. So first we need to find out what is the common potential. So first you try to get common potential after you connect the uncharged capacitor. So V common is equal to C1 V1 plus C2 V2 because they are connected parallel divided by C1 plus C2. So C1 is 900 picofarad, 10 to the power of minus 12. V1 is connected to 100 volts battery. Yeah. But V2 is 0 because it is uncharged. So therefore, this particular term will become 0. Denominator C1 plus C2. So 900 plus 900. So since they are picofarads, you can write this is 10 to the power of minus 12 outside. Yeah, so this minus 12 get cancelled. Then this is going to be 1800. So this is going to be 900 into 100 divided by 1800. So this is 2 times. This is 50. Yeah, so V common. After you get V common, energy stored after you connect of C1 plus C2 because they are connected parallel. So therefore, V common square because basic formula of energy stored is CV square. So since parallel C1 plus C2, so half into C1 is 900, C2 is also 900. So straight away you can write 1800 into 10 to the power of minus 12. With V common is 50. V common 50 means 50 square. 50 square means 2500. So just to simplify it, 1, 2, 3, 4. So this is going to be minus 8. So this is 9 times. So this is going to be 225 into 10 to the power of minus 8. Otherwise, joule. So otherwise, 2.25 into 10 to the power of minus 6. So first option is correct. Moving to the next question. Question number 16. The distance between the two plates of a parallel plate capacitor is doubled. So therefore, you call it as D2 is equal to 2D. Area of each plate is halved. So therefore, A2 is A by 2. Earlier, before changing, feel that D1 is D. A1 is E. This is before you change. Now final capacitance. So capacitance of the parallel plate capacitor is epsilon naught A by D. So therefore you write down C1 by C2 before and after. So anyhow epsilon naught is constant, so this is A1 by D1. So when initially C1 is C. So A1 by D1 divided by A2 by D2. So therefore D2 get multiplied to A1. So you can write A1 by A2 with the D2 by D1. So substitute the values. So A1 is A only, whereas A2 is A by 2. So 2 straight away will go up. D2. So what is D2? 2D. So D1 is D. So DD get cancelled. AA get cancelled. This is 4 times. So therefore, C1 by C2 is equal to 4. So therefore, new capacitance will be 1/4 of the first capacitance. 3 by 4. So last option is correct. Moving to the next question. Yeah. So the effective capacitance of two capacitors are 3 microfarad and 16 microfarad when they are connected in series. So therefore, get back CS is equal to C1 C2 by C1 plus C2. So CS is given 3 microfarad, remember. CP is equal to, you know the formula, C1 plus C2. CP is given 16. So they are asking you to find out C1, C2 values. Okay. Yeah. So there are two methods you can follow. You can straight away substitute here, 16 here. So therefore, C1, C2 is a simple method. C1, C2 is 16. So this is 16 is equal to 3. Okay, microfarad you write afterwards. So C1, C2 is equal to 16 3 is 48. Now, okay, so let us write that. You can say that either C1 is equal to 48 by C2. So substitute this straight away here. So C1 is 48 by C2 plus C2 is equal to 16. Now, if you take LCM will be C2. So this is 48. This is C2 square is equal to 16 C2. Otherwise, what you can do is minus 16 C2 is equal to 0. So take quadratic equations. I think 12 fours. Yeah. So C2 square minus 12 C2 minus 4 C2 plus 48 is equal to 0. So therefore, so C2, take out common C2, C2 minus 12. If you take a 4 common, so this is going to be C2 minus 12. Check it once, minus 4 minus 12, so minus plus 48. Yeah. So C2 either can be 4, otherwise C2 either can be 12. So once, if you take C2 4, C2 4 means what? C2 12 plus 4 is 16 anyhow. So therefore, you can go with C1 as 4, C2 as 12. Otherwise, C1 as 12, C2 as 4. So therefore, third option is correct. Moving to the next question. 6 charges plus Q minus Q plus Q minus Q plus Q minus Q. So out of 6, 3 are negative and 3 are positive. They are arranged at the corners of hexagon of side D as shown in the figure. Work done in bringing a charge Q0 to the center of the hexagon from infinity is. So therefore, work done expression you write down. Work done due to two system of charges. So therefore, W is equal to work done due to this. Work done due to these two system of charges. Yeah. So therefore, it is going to be 1 by 4 by epsilon naught first pair. Q0 and minus. Q naught and minus Q. This is the first pair. So distance is anyhow same, R plus 1 by 4 by epsilon naught. Now you go plus Q, left side of minus Q, previous one. Q and plus Q divided by R plus 1 by 4 by epsilon naught. Okay, so next charge. This is, sorry, Q naught with minus Q, this charge, minus Q. Distance, R, distance are nothing but, if you divide, there will be 6 equilateral triangles, distance will be same. So therefore, this is R. Yeah. After this, plus. So how many are over? 3 are over. 1 by 4 by epsilon naught. Next, this is plus Q. Therefore, Q naught and plus Q divided by R. 4 are over. 1 by 4 by epsilon naught. So therefore, this is Q naught minus Q divided by R plus 1 by 4 by epsilon naught. This is last. So Q naught plus Q. Q naught plus Q divided by R. So therefore, look at this. This is minus Q, this is plus Q. Magnitude and distance here. Minus Q plus Q. Minus Q plus Q. So answer is 0. Yeah. So first option is correct. Moving to question number 19. Yeah. The equivalent capacitance of the system shown in the circuit is, this is given 23. So assume that these two are first parallel. So first parallel means what? CP is equal to. So they are identical. Directly you can write C1 plus C2. It is going to be 3 plus 3, 6 microfarad. This 6 microfarad in series to 3 microfarad. So therefore, CS is equal to CP first one. Okay, you call this as C3. Divided by CP plus C3. So CP is 6 into 3 microfarad, you can write afterwards. Then this is 6 plus 3, 9. Therefore, this is 3 times. This is 2 times. So answer is, final answer is 2 microfarad. Last option is correct. Moving to the next question. Yeah. Okay. An electric dipole placed as shown in the figure. The electric potential in 10 to the power of 10 square volts at point P due to dipole is, so epsilon naught is permittivity of free space, and you need to write 1 by 4 by epsilon naught as K. So get back potential of negative charge at the given point P and potential of the positive charge at the given point P. So therefore, potential due to negative charge is 1 by 4 by epsilon naught, that you can take it as K. So Q by, this is due to negative charge, you remember, negative charge. Distance is about 3 plus 5, 8 centimeters. Plus potential due to positive charge. Positive charge is here. Total is 5 from the center of the dipole. So exclude 3 from 5. So that will be the distance of the point P from positive charge. So therefore 1 by 4 by epsilon naught. So Q by, this is a positive charge, but what is the distance? 2 centimeters. 5 minus 3, 2 centimeters. So now 1 by 4 by epsilon naught, and Q also you can take out common. So QK, 1 by 4 by epsilon naught, first you write down. Then this is going to be 1 by 2 plus minus 1 by 8. So therefore, this is 1 by 4 by epsilon naught is K, QK, LCM is 8. So this is 4 minus 1. So therefore, this is 3 by 8 QK. Yeah, so last option is correct. Students, In my next video, I'll continue explanation for previous NEET questions from the chapter current election. Don't forget to share and subscribe with your friends and relatives. Thank you very much.